All right, let's get right into it. When you think of the operating room, you probably think of a sterile, controlled space. But what we often overlook is a pretty significant source of pollution hiding in plain sight. I'm talking about anesthetic gases, and one in particular, desflurane, has a huge environmental cost. So today, we're going to break down the case against using it routinely.
So, just to get a sense of the scale here, let's start with this number. The entire global healthcare sector, our industry, the one dedicated to healing, is responsible for about 5% of the world's total greenhouse gas emissions. I mean, think about that. If healthcare were its own country, it would be the fifth largest polluter on the entire planet. This isn't some minor detail, it's a massive issue.
And this really puts our professional responsibility into perspective, doesn't it? The Lancet Countdown, one of the top authorities on this, doesn't just call climate change an environmental problem. They call it a fundamental threat to global health. What that means is the choices we're making inside the OR have consequences that ripple out way, way beyond the hospital.
Okay, so let's zoom in on desflurane's impact. The key thing to understand is that not all inhaled anesthetics are created equal. Not even close. And when we put the two most common ones side by side, a really dramatic story starts to emerge.
The main way we compare these gases is using a metric called global warming potential, or GWP. The easiest way to think about it is like a power rating for climate change. Carbon dioxide is our baseline, right? It has a GWP of 1. So any gas with a higher GWP traps more heat, which makes it a much more potent driver of global warming.
And this is where the difference just becomes staggering. Over a 100-year timeline, sevoflurane has a GWP of 130. Now, that's already 130 times more powerful than CO2. But then look at desflurane. Its GWP is 2,540. That is a massive difference. Its climate impact is almost 20 times greater than sevoflurane's.
To really bring that home, let's put it in real-world terms. Imagine you're doing a standard 2-hour case using sevoflurane. The carbon footprint is basically the same as driving a car for about 16 miles. Okay? Now, what about that same 2-hour case with desflurane? Well, that's like driving 378 miles. We're talking about a drive from Los Angeles all the way to Phoenix for a single surgery. The choice of agent just completely changes the entire environmental equation.
Now, to be fair, there's a bit of a scientific debate here. The GWP metric is the standard, but it does have its critics, especially for gases that don't hang around in the atmosphere for centuries like CO2 does. So let's take a quick look at the other side of the argument.
So desflurane has an atmospheric lifetime of about 14 years, which is nothing compared to CO2's centuries. Climate scientists call it a short-lived climate pollutant. And what that means is its warming effect doesn't just build up forever. If we were to stop all desflurane emissions today, its contribution to warming would actually reverse and disappear within a couple of decades. That's a completely different behavior than the long-term warming we get from CO2.
But here's the thing. Even with that scientific nuance, the policy consensus in healthcare is crystal clear. Major systems like the NHS in the UK and the entire European Union are actively phasing out desflurane. And their logic is super straightforward. When you have a perfectly good, clinically equivalent alternative with a much, much smaller environmental footprint, you have a responsibility to use it. The goal is to cut all emissions wherever we can.
Okay, so let's move beyond the environmental debate for a second, because there's an equally powerful practical case against desflurane. And this one centers on two things that matter a lot in any hospital: cost and, of course, clinical benefit.
Take a look at this number. This represents the potential annual savings that some hospitals have reported just by getting rid of desflurane. The economic argument is just as powerful as the environmental one. We've seen quality improvement projects save anywhere from $30,000 to over $100,000 a year. That's real money.
So what this really creates is one of those rare win-win scenarios. Desflurane isn't just the worst for the environment, it's also the most expensive agent we have per milliliter. Switching to something like sevoflurane is a move that helps the planet and the hospital's budget. It just makes sense. But of course, for any of us who are clinicians, the most important question is always this: what about the patient, right? Environmental and economic factors are great, but they come second to superior clinical outcomes. So, does desflurane deliver?
Well, when you actually look at the clinical evidence, the claims about faster emergence, yeah, they're technically true, but we're talking about a difference of just a few minutes. And that faster wake-up has shown no demonstrated improvement in things that really matter, like getting patients out of the PACU sooner or reducing post-op complications, even in really high-risk patients.
In fact, the evidence actually points to some specific risks with desflurane. Studies have linked it to an increased risk of post-op delirium,
more significant cardiovascular depression compared to sevoflurane, and of course, its well-known reputation as an airway irritant that can cause bronchospasm. So when you weigh this tiny, insignificant benefit against these known risks, the clinical case for choosing an alternative gets really, really strong.
So, the evidence is pretty overwhelming on all three fronts, right? Environment, economics, and clinical care. It all points in the same direction. This brings us to the most important part, the path forward. How do we take all this knowledge and actually make meaningful changes in our day-to-day practice?
It really comes down to 4 high-impact strategies we can all adopt. Number 1 is simple. Prioritize the low GWP agents. Just choose sevoflurane or isoflurane instead of desflurane. Second, always use low fresh gas flows to minimize waste. Third, try to avoid nitrous oxide. That's another really potent and long-lasting greenhouse gas. And finally, whenever it's clinically appropriate, embrace TIVA and regional techniques. They have the lowest carbon footprint, period.
At the end of the day, this all comes down to a fundamental question for us. Given the overwhelming evidence that desflurane offers no significant clinical advantage, costs us more, and carries this massive disproportionate environmental burden, what is our ethical obligation here? An obligation to our patients, to our communities, and to the future of global health. The data really suggests the choice is clearer than it's ever been.